The song goes, I love rock and roll. Make a ton of char in a rock kiln, baby. No, I'm not, obviously, my profession is not entertainment. Okay. Uh, I'm talking about what is called rock and roll kilns. It's based off of the RoCC, rotatable covered cavity kilns, which I've presented about before. I'll give a quick summary of that. Looking at the small sizes for woodlots, fields, and residential biochar production. I thank Christian for having me back on the webinar series, and I'd like to point out that Gary Gilmore is who is on the line, and he has definitely had content in with this. And Gary is the co-inventor with me of the now with patent protection rock kiln. So ready to go to my next. Okay, just get myself in the right buttons here. There we go. Okay, building upon the previous presentations, this was back on the 25th of June webinar this year, and I did go over this kiln. I picked 5 out of the 46 slides to be reshown here with some minor editing to it. The rock kiln is definitely a Flamecap, or also sometimes called flame curtain technology. It is the classic Flamecap is also in a cavity. It's a container of sorts, and they have open tops. And I did a one with a closed top on it for a number of years, and eventually put it in for the ability to rotate it. That's to help it mix it up. So the two methods are contrasted in the two diagrams here, and I'm not going to go over what it is, except that, I mean, you'll see how it's going. The char accumulates in the bottom where there is an absence of oxygen, because all the oxygen is being consumed up above, and the radiant heat coming down onto it gives us our pyrolysis to continue with the making of the I am moving my cursor on the wrong screen. I have to have it on one screen in order to advance. There we go. All right, I can do it this way here. Also, I pointed out that there's different sizes, and this is in terms of orders of magnitude from laboratory size up to industrial size, and the need for things which are in the medium categories in here. The rock and roll kiln is definitely in the midi, or maybe it should be mini size. It does about 25 kilograms of biomass input per hour. And if you're doing it for 10 hours of operation, you probably wouldn't run it 10 hours continuously yourself. This is a personal size unit, and you're going to spend a whole day on it. You could, but in 10 hours, you'd get about 50 kilograms of char coming out of it. This is the rock kilns, which have rollers on them, and therefore the barrels will roll in a stationary position, and this is how it gets the mixing of it going on. But we wanted to come up with something a little bit different than that. So all of these kilns, with the movement of it, we have these 6 positions, A through F. I'd like to point out here, because I will refer to in this talk the A position, the front side. In this case, when you're looking at the unit from one of the ends, the opening is to the left in this case. The hood and chimney are the key factors for identifying where is the front side. And in the B position, the opening, or I call it the portal, is turned upward for the gases to go straight up through, and this is very much diminishes the amount of flame because it keeps the air from coming down in and circulating like it does in the Flamecap. You can also rotate it so that it is to the back side and easy access for putting in fuel without any interference from the hood and chimneys. And then the D, which actually conveniently corresponds with dump, or down is when you're emptying it out, and then it movements around through there. So that is this diagram shown today. I've added on this hood and chimney part, and this is definitely the correct representation of it. In the manual that is on the internet, I've got the A and C. There's some differences, but this is the way that it should be referenced and the right references to it. I discussed in there the costs of these rock kilns and disregard the big sizes on the bottom, but you could do it in a barrel, do it yourself, and you can use scrap and things which I have made. You'll see some things in what Gary has made, which we didn't really run off and buy a whole bunch of stuff to do it. We had things around. You can also purchase it ready-made, a few $100s perhaps, from hoping some people will become suppliers. And I noted at that time in June, a less expensive variation could be available by August 2020. Well, we passed August, and so I'm showing what this is here. This is the rock and roll. The basic components of a rock and roll kiln. There is one barrel. Mostly we deal with a 55-gallon drum, but it certainly can be larger. If you're getting, that's almost a 2-foot diameter barrel, 3-foot diameter easily could be very nicely in it. If you went to 4 feet, I think you would have trouble moving it. So it's not, we're probably down in this 2-foot to 3-foot diameter unit into there. That has a hole or a portal put in it. The second component is the frame, which holds up the end brackets and the handles, and then the hood and the chimneys that are on it. So starting off with the barrel itself, 55-gallon drum, there are descriptions in the document, which was the draft here. I haven't updated the draft discussion document, but there's text in there giving information on this. And we run out of time. We're looking for volunteers. We're looking for people to help. Anybody who wants to get involved with this, you're more than welcome. So this measured on the curve, this portal is about 13 inches, and it's about 12 inches if you measure it just straight across the opening after it's been cut through. Okay, it's a simple cut with an angle iron. Leave a lip on the end, keep the integrity of your barrel there, but you're not going to use much of that lip. The frame has several components. The first one here on the left, it has I'll call them the wheels. You'll notice that the upper one here is circular, and the lower one is an octagon. And the octagon has proved to be a bit more difficult to, not just only to make, but also to use. And I'm going to recommend that we just use the round ones. And if we need to prevent it from just rolling away freely, there's several different ways of helping to that. So we'll go with the round ones on here. The crossbars on there are so that it can be attached to the end of the barrel. They are 16-inch centers between these pipes, rods, whatever it's going to be. In my case, I do not do welding, so I'm using nuts and bolts to put things together. People who have welding capabilities, it becomes even easier. With regard to the rolling, getting it round, take it to a place which has the right equipment and get it rolled. This shown here is electrical conduit. It's a thin-walled, not quite half-inch diameter pipe, and there's some mounting things that we've mounted it on the edge. But it could be welded onto those edges. There could be blocks put underneath to hold it into there. So this is how this comes in. Obviously, these ends that got cut off eventually onto there. There is in the center, well, we're looking at the center of this barrel, I have a hole with a large bolt in it. Gary's unit has a welded plate and then a pipe that comes out from that, coming out vertically from that center, and that becomes the axle for the unit. You can see that over here in this picture on the right-hand side, just a bolt in there. My stuff's pretty flimsy. I'm proving concepts, but I can tell you that It does work. I've used it several times in different circumstances, even some different fuels with it. Do not copy what you're seeing in the diagrams. It can certainly be made better and nicer where the hood is related to it. Those are discussions that we can do separately and the fine details with it. Rock and roll kiln sequence. We got the fire going. This is in my backyard, and I have not had complaints and neighbors coming in or anything else. Yes, you get some smoke. Do not let anybody convince you that a Flamecap kiln, open top or a covered cavity is not going to give you smoke at some times. Eventually, I believe this issue will be diminished as we get better control over how we're allowing the air to enter, different hole mechanisms, different sizes and things like that. So, but when it's functioning, when there is a fire and you don't want to lose the fire, if you lose your flames and you have biomass in there still pyrolyzing, you will have smoke. That's the definition. That's what smoke is. It's a combustible material. And you just be ready, get it relit again. And if it is burning, the flames just come up and they go up through these nice, the chimneys that are there. My chimneys are simple galvanized 8-inch heating and air conditioning ducting, not the heavy duty kind. And you'll notice that on much of it, the galvanizing has not been burned off from it. It's not that hot. I mean, it's hot, very hot, but it didn't impact the galvanizing on it. We're running this by throwing in the food. This unit is in the A position. The portal is underneath the hood and the flames going up through it and into there. There could be a lip down on the front end of this to help minimize it, especially on a windy day. I have a little flap in the back, which I just put onto there. This becomes part of the usage. The handle here, which comes out from the pivot spot, I like to keep it horizontal to the ground. I've got little legs here. You can see it better on this side over here. There's a little leg post put onto there to keep it up at that position. So this is now going to keep my hood, which is attached to the handles. These are tie rods in here. It pivots on the axis, but there's a tie rod on both sides that will then keep it from shifting around. You raise up this handle a little bit. These legs come off of the ground a little bit. You've tilted your chimneys a little bit, and you can roll the unit around even when there's fire in it. Obviously, you can't go upside down with it. You're going to dump everything out, but that's you can do this for the mixing. So I was using fairly substantial chunks of cordwood from my backyard. It's been pretty old stuff and dry, but I'm not worried about throwing in something which is 4 inches, 6 inches in diameter, and you've got to let it be in there for a long enough time. I would like to have a reinforcing edge on the lower lip here, maybe even on the upper lip, but especially on the lower lip of the portal, so that I can stick a pry rod in there or something else to help mix it up. You can also access to mix it up through the end panels, these are other things still being developed and working on it and things like that. So after it comes down here, I removed with tongs the uncharred large pieces and just snuffed them out in a separate trash can. And I ended up with a bed of charcoal here at the bottom. No smoke coming from that. That's hot char. You leave it like this, open to it, it will burn all the way to ash. So, but it's not like you got to do it immediately and rush to have it out there. I should point out that when I start the unit, I like to put a small bucket, maybe a gallon's worth of pre-made cold charcoal in the bottom, just so that I don't have the new wood and everything just sitting straight on the cold bottom of the unit. So then it comes time to move it, and I raise the handles. I roll the unit. In this case, I'm rolling it toward me. It could be dumped out the other side by pushing it more rotation further away. But in this case, I'm moving it toward me, and it is coming and it's dumping out the char down onto a container, onto a receptacle, whatever you have for it in there. And the reason that I have then these three pictures, and by the way, this is about an hour and a half of usage, and I ended up with 10 gallons, and that would be 40 liters of char into there, and it was dumping it out. But then I went and I dumped it further, and you'll notice the black on top here. This is definitely the char which was in the bottom of the container, the one that had the least air onto it. Could have been some of my original char that I put in also, but I'm quite sure some of this is created char in here, and it dumps out. It is not glowing red hot when it comes out in this particular case, this particular time. I noticed this only when I saw the photographs afterwards, not during the time of doing it. So it uses it and operates it like a Flamecap kiln. Now to Gary Gilmore's rock and roll, and he has, Gary comes up with interesting variations. Gary's a forester, and Gary is a blacksmith, or blacksmith training. He can weld and I can't, and he's got a scrap yard bigger than my scrap yard, and that's saying something. So anyway, he's got the things here. So his unit, without having the hood on it yet, sitting on it, you're seeing the barrel down in here, similar proportions and everything. He has a pivot coming out the end, an axle. Onto that, he has his handles. His handles are angled downward because he does not have a wheel which is going to raise this whole unit up about 6 or 8 inches off of the ground. Depends on how big your wheel is, of course. So mine, I get it pretty much horizontal. His is at a bit of an angle. The angle also has the advantage, and he's using a shelf here, that you raise it a bit more and slides off of that shelf, and you can actually slide it into the unit while it is functioning, or you can just push it with a rod or push it with your hand, slide it off of the shelf into there. His shelf is supported by a cross member here, which actually can tie together the two handles, and a second piece which is up above into here. Really simple, very nice. Don't have to make the wheels and stuff. It rolls differently, and you're going to be putting a hot barrel onto the soil. You don't want to necessarily run that across your backyard, but when it's hot, you're going to burn your gases. So this is a diagram that was into here, and that he had built, that he had made before. So I would, in terms of people who might be wanting to make one of these things, a change, and Gary can speak up for it, but I would move this leg here, or this, you see it in the back here, this leg, and I would just have a shorter leg proportionally up closer to the barrel, and that way makes no difference. The legs actually help keep the barrel from rolling away from you once you've got it set in place and it's going to be there. So now, with regard to the hood on his, he has built a hood. Again, he welds. It's a nice, strong hood, and not the sheet metal stuff that I've used. Chimneys put on there. I should ask Gary, how come he doesn't have matching colors? But he's laughing now when I say that. I'm just kidding. And his hood sits on. It's a firm structure, and it's got a leg, and this comes down, and we call this the shoe, or the support bar. And look at this bottom piece down here. I've got a bigger picture of that coming up here in a second. So this is his unit in operation, and okay, in the C position, this is on the back side of the unit, okay? There it is, the opposite on the front side. You're seeing the shelf here, the hood and chimney comes further over the front there. This is how you identify the A position for it. And the chimney stubs that are here, that you can attach them, you can make all kinds of different things on it. But now about this piece here, the long one. There we go. Notice that it is, in this case on the right-hand picture, the shoe, I call it, maybe he has a better name, fits down onto the leg. If the leg is round, it could be a rounded piece, it could be square pieces, it can be something, and it rests on it by the weight of the hood. But here he's showing by hand, he's actually picked it up, and the shoe, therefore, is not attached to the rail, to the handle. And so actually he is able to remove his hood easily. I mean, you got to be a grown person and be careful you're not dealing with when it's too hot. But or you could actually have other handles, other ways on. But you can take off the hood. You can transport it separately. The hood is separate from the unit. I'm going to check my watching the time here. So I like this very, very much. The ability to do that. Here you see a good view of the end plate that he put on in order to give strength to the end of the barrel. And here is his pipe, which is his axle, and it comes out. It does not go all the way through the barrel. He has one of these plates with pipe on both ends, and then the handle fits onto that, and so you can pick that up, and the hood has its own frame with the shoe to sit into place. Okay. Now I'm going into some other variations on it. This unit here has never been built. It is in design mode. A better design is being made now in India by some people over there at IMMT in Odisha. My thanks to Rajesh Mandal, who's an expert on it, and we have 3D CAD drawings, etc. What we're seeing here is a variation intended to be rolled through a field. I want you to imagine a harvested field of rice or wheat, and the straws are there and all this type of stuff. And if they can't get the excess biomass off, they've taken off the crop, if they can't get rid of the excess biomass before it's time to replant, they torch it. They light fires on it. It burns it, and these massive clouds of smoke and causing air pollution. The Asian brown cloud that extends from Beijing, from Delhi, and then over on through China, and you find it in Latin America. You can find it in Africa also. The burning of crop residues. So I think of this unit as like a rickshaw, where instead of a person sitting in there, there is a barrel, and the barrel in here, the pyrolyzer, is in dashed lines. It doesn't show well. You have to pay attention to see that these dashed lines inside are the outline of the barrel. And that barrel now moves separately from the frame, and it moves separately from the wheels. And by using a braking system or an attachment system, you're able to make it so that the barrel will be fixed with the handles, the frame, or it will be fixed with the wheels, so therefore it will roll and rotate the barrel when you roll the wheels. This is about 6 feet in diameter, which would be 2 barrels in length, but it could be made of new material. It could be any length that you'd like. The operators have these handholds on here to pull it, and this needs to be filled in here. This is a shelf, like Gary had his shelf with corrugated material on it, lightweight material. Taking it through into the field in there, they've raked up the biomass, and you flip it up onto the onto the shelf into there. And you can then be pushing it from that shelf into the mouth, into the portal of the biochar maker, and the pyrolysis going on inside there. And when you are dealing with lightweight material like straws, or I had an excellent example or experience with hemp stems, and boy, I could just be pushing them in almost as fast as I could manage, and they would be consumed in the fire inside the kiln, and giving me the char, which falls to the bottom where there's no oxygen and it accumulates. So the idea is that a team of 2 or 3 people would be taking this through a field and rolling it just straight along and get to the other end and turn around and come back another direction, and to put the biomass up onto the shelf, into the portal, make the char, and when it gets full inside there, they would stop. You maybe probably dig a trench in the agricultural field that's out there, roll it forward to or backward to dump all of the char into that trench and cover it over with the dirt that you took out of the trench and get it to be extinguished. You don't need to bring in water for doing it. We have to have a solution which is extremely functional and practical. Now, the cost of the unit adds money, and the poor farmers aren't going to be doing it by themselves. And they'd like to be for their labor. The issue is with regard to having value for the char, and this char for their fields, yes, but also the value of the char for carbon sequestration for climate purposes, which I'll talk about in just a second. I'm getting close to the end here. This is a drawing, a sketch of the unit that is being built for me in Goodfield, Illinois at Paul Weaver Construction Equipment. A perspective of the size. The box is a 20-foot shipping container. Can be picked up with forklifts, can be moved and all those things. Inside that box, there is a 6-foot diameter rock kiln, and it will roll along on the floor on rails on the floor. The rails on the floor. When it's motorized, mechanized, a unit up here, it's powered down a chain, a pillow block movement into here. You're loading it at this end by the doorway, which is open, and then you can turn it this way, so a little bit up if you'd like. The emissions will be going up through the chimneys, substantial chimneys, and I'm envisioning the size of 55-gallon barrels, again, almost 2-foot diameter chimneys for this size of unit. This over here is actually a door that comes down over another opening here, so that when you are in the B position or toward the C position, you can actually just drop the fuel in straight down in. You don't have to come in and load it in. You could do this with a forklift and have different ways of, or a claw and things, and they're going to dump it down inside there. Mechanization has not been put into here with regard to fuel loading, but that's something that engineering can solve. What we're talking about here is how to accomplish the pyrolysis. So you can rock this back and forth to the A, B, C positions, and you can get like almost 270 degrees of rotation to get the mixing into there. And then it becomes making your pyrolysis. So this unit, 6-foot diameter, is 7 feet in length, and it fits inside of a shipping container, which is 8 feet in length. They got 6 inches of spare on each side. Rolling it forward all the way to the end, there is another opening in the doorway, and a hole in the bottom of the container. And if the container is either up on an incline, or better yet, if it's just raised up on some blocks, it's raised up, there's enough space in there, it will dump out, and you can remove the char then easily from there, either to the back or toward you from to the side into here. Mechanize it, get augers, get trays, get whatever you'd like with it. That is not what I'm trying, that is totally possible. I'm not saying it is put into my unit because of the extra expenses on it. Kurt Spokus, you're involved with on the list, or if there's anybody with the Forest Service, we'd like to have this unit put to the test. I mean, we will test it first in Illinois at Goodfield, but we hope to have this thing ready by the middle of December. So certainly for this winter and things. This is the type of unit to go the bigger system. Sorry, this is, I don't really call this rock and roll. I mean, this is the big size of the rock kilns, and I basically got off target for my talk, but I wanted to put that in. My contact information, I'll come back in. I want to point out that My website for wood gas pyrolytics, the company, is now changed to woodgas.energy. Woodgas.org is now been reserved for the nonprofit elements that we're working on with James Schoner. So I'm still Woodgas, but it's woodgas.energy, and there will be shifts back and forth between them. There are discussions in here today. Right now, we are in this presentation here. On December 1st, I am going to be releasing my white paper called Time for CDR with Biochar. CDR is carbon dioxide removal. With biochar, it is absolutely heavy about the climate impact of biochar, not about the soils and the mycorrhiza and all that kind of stuff, which is also important. The pardon, there's a comma there, shouldn't be. It should be a period. Now, in that's the 1st of December. Then National Biochar Week is the 7th to the 11th. It's a free thing with Zoom, and you can sign up for it and attend it in those sessions starting at 11 o'clock. And on all those days, and there's great types of stuff coming along. I have put in a paper to present there on financing biochar and energy, BC&E, via carbon dioxide removal for climate remediation. They have to accept it and give me a time slot. However, on the 10th of December, which is the Thursday of National Biochar Week, the Green Carbon webinar, which you are attending today, that means 4 weeks from now, they will have their broadcast starting at 8 o'clock. And Christian has authorized me to use this time slot there, and I'm going to draft in Gilmore and probably Hugh McLaughlin and some of the other people. We're going to be talking about it, and I want to go over the issues of how we can use biochar as it's described in this white paper with regard to with regard to climate change and climate things. So I've got there's a 40-page document. It's written. I'm doing polishing now, but inside of it is this diagram. It talks about the different types. I'm not going to go into that right now, but BC&E, biochar and energy. If BECCS can get energy in, and then they carbon capture and sequestration on, biochar can get energy into it also, okay? Now, the important slide is this one. It's a different variation on it, but the two sources for removal is pyrolysis and sorbents. And the sorbents is infinitesimally small. Photosynthesis is great. Crops have a very short lifespan of sequestration. They're going to rot out. They're going to change soil organic carbon. It dies, but it can reproduce itself. So is it going to be this is a logarithmic scale of time, by the way. So is it from less than a year to more than 10 years? Is it going to go hundreds of years? I'm not so sure. Forests, go for it for 200 years worth of forest sequestration. That's all short term. In terms of the climate, world climate, the short term stuff is you got to get more than 150, 200 years. The only two methods which are longer term, which I am finding, are the inorganic compounds, which come from these sorbents, and they can go on for that, but I don't know anybody that's going to be around here 8,000, 10,000 years from now, but we just got to get to the 1,000 bracket, okay? And biochar, which is the pyrolytic interception of all of this biomass so that we are then able to make it into something which has the permanence which is needed. Biomass by itself lacks permanence. Biochar gives us permanence. And if the world's in a climate crisis, I think biochar is going to be one of these. It's not the silver bullet, but I'll call it the black bullet or something like that if we need to. Finishing off, this is the different ways we use it. We make the char, you got the heat, to get rid of biomass, like out in California, these problems. Climate credits, offsets, and there's the picture of the bigger kiln that was out there. These prongs, we don't have those in our small rock and roll, but we can put them in, or we could have a grate that's put onto that so that when you tip it, only thing that will come out is the finished char and the bigger pieces will stay inside. And this is what you don't do, how I started with it, but it's made with pipes and didn't work, so don't replicate. Thank you very much, and sorry I have to check my clock if I ran out of time, but you know, sorry there. Okay, got a few questions. And I'll give you back the screen, right?
Yeah, you can also keep it if you want to. So thank you very much, Paul. Again, really interesting presentations, and I'm really looking forward to see the big version of the rock and roll kiln in action. Maybe next year another presentation. So you got a couple of questions. The first from Przemysław. Do you have any control of the process using the reactor, such as temperature or heating rate? And do you have very heterogeneous biochar as a result?
Okay. The heating is a vigorous flame, and the radiant heat that comes down from that are actually the flame burning the gases as they're coming off of the biomass. So we're getting in this, I like to think it's 500 centigrade to 600 bracket, somewhere into there. Pretty consistent. You're not going to get hotter than that because we're not equipped for that, but you would get lower than that only if you do not have the biomass exposed to the heat, to the oxygen. You got to get some oxygen in there to burn off these gases. So as long as you don't have your biomass buried down underneath, you're able to then get all of it exposed. So I never put in fresh, I don't usually put in any fresh biomass in the last half an hour so that I'm burning off and things, and I try to do the mixing and the turning of it and with a pry bar and stuff like that. And so I do not think I have much variation within the char at all. Gary Gilmore has been doing it also. He's been doing char a long time. And we refer to something called engine grade biochar, which is used for char gasifiers to give you gases for engines. And that you need the chunky pieces and stuff like that. Much depends on the type of fuel that you're mixing in, or the biomass that you have. Small stuff, stems and things are going to be pretty small when it comes out, just by nature. But if you're starting off with wood, you can come up with some nice pieces of char into there. I hope that gave the question, answered it.
If not, Przemysław can write again. So the next question was from Ramune, I think. So what quality parameters of biochar quality do you check? Is that production useful in agriculture, like soil amendment?
Okay. The testing of my chars I don't get them tested nearly as much as I'd like. Part of it's finances and stuff, but they've been tested. McLaughlin has tested some of them that came out of the 4C kiln. This is back before it was able to rock and roll. This was before it was able to rotate. I had that unit for 5 years, from 2014 to 2019. And so we tested some of that. Chars are reasonable. We're not claiming them to be excellent, okay, or fantastic. Certainly they can go into soil purposes and stuff. It is not charcoal that you would say you're going to use it for cooking purposes. I mean, we're not making the old traditional way where they've got volatiles and stuff in it.
Okay, thank you. And then another question is, how tolerant is the burner for damp fuel? So what about moisture?
Say again, the what?
How tolerant is your burner for damp fuel?
Oh, okay. If the fuel is going in damp, you will have difficulties. And that's just the general across the board and just about all pyrolyzers. And we notice the difference if we've got moisture contents of over 20%, for example. I don't do much testing of that, but I know basically I got some pretty old stuff or I got some newer things that go in with it. the a big factor about the rock kilns, as opposed to the flame caps, are we have our heat going out through chimneys. And if it goes through a chimney, you are therefore able to control it and capture it. Capture in the sense of redirect it by fans and blowers down through a wind tunnel, through tunnels, through pipes, whenever, not pipes, more like ducts. And you can put these hot gases use them for the purpose of drying. Now, these gases have emissions in them, so you're not going to put it onto onto food grade products that you're trying to dry out, but you can certainly put it onto fuels which are going to be destined to be going into your pyrolyzer. Because you want to dry at something like 100, 120 centigrade, 80 centigrade to 120 centigrade, you don't want the full temperature of these gases as they're coming up the chimney. So therefore, sending it through the ducts and with extra air blowing in it in order to help make it go actually works in your favor. A large volume of air blowing down through the biomass, which is heading your way to become your fuel. Now, the engineers in the group, you have to work out and the amount fuel that you need, and therefore it should be drying for 4 hours. It should be drying for 4 days if they're operating with this. So this is all be done, but we have the heat and it's capturable. And again, looking for people who would say, hey, I'd like to work on that, and have them put that to use.
Okay, then we have I think that was a suggestion to use the soap test to check how cooked the jar is. We heard it in a previous presentation.
On that, I have no problem with my jars in the sense of there being the greasy types where you've got to use the soap to get your hands cleaned afterwards. And believe me, I get dirty. I mean, I get my hands dirty with this stuff, and that is not an issue. So that in that regard, my jars pass very nicely.
And then another question about the different type of equipment. What about using a home oil tank for a rock and roll kiln instead of a steel drum?
An oil tank, if it's circular, it would work fine. You can make it as big as you want, but eventually you'll get to a point where you could be being too much to handle. Now, I welcome anybody that's going to make something and send us back then information about it. Tell us that, oh, we made this thing and we only used it 3 times because we needed 5 guys in order to turn it and operate it. Well, that's a learning experience. Or they say, hey, it works really nicely as long as you have, I mean, some people have a mechanical way to cause it to roll and rotate. I mean, the one in the container, this is a big example, and it's basically on the same principles as the rock and roll. I'm just not going to use that name for it. Oh, sorry. In terms of a scrap oil tank, yes. And the term for that is obtainium. If you can obtain it, use it.
Then there was a suggestion or a question if you can include water pipes to heat water over your lid cover, if you think something like that could work.
Okay, I'm interpreting that as being under the hood, not in the tank. Beautiful idea. I'd love to see the results of how somebody's using that, and then they can they're accomplishing their water usage, their water heating.
And then John Webster is asking, what is the anticipated budget for the container version?
It's going to be under $50,000. It might be around 35. It might be less than that, but we've got to get one belt, and we also have to prove that it works. Okay. If I need to make 4 versions of it, the prices will be going up. But no, I think it's going to come through in there. So I can't quote a price, but if anybody is interested in participating in that, financing it, or you want to be on the list to buy one, or you want to have the first unit, and just contact me. My email address is all over the place, P. Sanders. I think people can find it, but I welcome calls on international stuff, WhatsApp, Skype, all that.
Okay, thank you very much, Paul. I think we are good in time.
I'd like to make one extra comment, though, please.
Yeah.
On this call, I saw his name is Luca. And Luca's an Italian who's now living in Colombia, South America. And through WhatsApp and calls and things, I have talked him through the building of a rock kiln. It is slightly prior to being able to direct him toward the rock and roll. But this is with wheels and stuff. So he is able to say, we work with people everywhere. These rock kilns, South Africa, India, Colombia, United States. We've got this type of stuff around looking for people. The guy in Australia too. Yeah. Thanks very much, everybody.